Euclid's Elements, Book 1, Prop 45. To construct, in a given angle, a parallelogram equal to a given rectilineal figure. So let's have a given rectilineal figure. Okay, we'll call this ABCD. This is a quadrilateral, but it could be bigger than this. And let's have a given angle. We'll call this E. And so what we want to do is make a parallelogram equal to this using this angle. The first thing we can do is we can connect this and break this rectilineal figure up into two different triangles. We have triangle 1 and triangle 2. And what we're going to do is build a parallelogram equal to triangle 1, and then build a parallelogram equal to triangle 2, and then prove that together they make one continuous parallelogram. So the first thing we're going to do, and this has got a lot of steps, so we're going to have to really keep track of everything here. We're going to use Prop 42. And Prop 42 allows us to construct a parallelogram using a given angle equal to a given triangle. So we're going to make parallelograms. Let's make a parallelogram here in blue. And this is going to be equal to angle E here. So let's call this parallelogram FGHK. So we're going to make parallelogram GK equal to triangle 1 using this angle. And then using Prop 44, Prop 44 allows us to do the same thing as 42 except to put it on a given line. So instead of in the other line, we're going to take this particular line. We're going to construct a parallelogram equal to triangle 2, but it's going to be applied to GH. And so it's going to look like this. Just a second. Okay, so this is equal to 1, and this is going to be equal to 2. And we're going to use the same angle, angle E, to construct our second parallelogram. So we really have two parallelograms here, even though they share this common line. We have a blue parallelogram, and applied right on that same line, we have a green parallelogram. So that's going to be parallelogram. We'll call this K, J, L, and M. So we have parallelogram LH that's equal to triangle 2. Now it would seem like we're done at this point, right? We have a parallelogram that each of the parts are equal to each of these parts. Therefore, this whole figure is equal to this whole figure. We're done. We're not done because we have to still prove that these parallelograms, while they share the same side, that these sides of the parallelograms are in line with each other. Because it could be that this side HM doesn't line up with KH. It might be like this. So it might look like this, or it might look like this. So we have to make sure that we have to be able to prove that this line HM is in line with KH and not kicked off up above it or below it. So that's what we're going to do for the rest of this prop, is prove that these are in line, and therefore this whole figure is a parallelogram. So the first thing we're going to do is we're going to note that since the angle here, we'll call this angle 1, and angle 2, since they're both equal to angle E, they're equal to each other. That's just common notion 1. So angle 1 is equal to angle 2. And which means we can add this angle here, 3, to both sides, right? So this is equal, so we're going to add angle 3 to both sides. And that will preserve our equality. Therefore, angle 1 and angle 3 is equal to angle 2 and angle 3. But here's the interesting thing. Angle 1 and 3, they are same side interior angles in this blue parallelogram. And this blue parallelogram is cut by a transversal, so it makes the same side interior angles equal to 2 right angles. Therefore, these are equal to 2 right angles. This is according to Prop 29, the same side interior angles. Which means angles 2 and 3 taken together are equal to 2 right angles. Well, the interesting thing about that is that Prop 14 says when you have a line and a point on the line, and you have two lines, this green line and this blue line, meeting on opposite sides of this line at the same point, if their angles taken together equal 2 right angles, then those lines are in line with each other. Therefore, FG is in line with GL. and this is one continuous line. So this line is parallel to this. This whole blue is parallel to this. We haven't dealt with this yet, but now let's look and see what else we can know. Well, we know that if we look at this parallel line and this parallel line cut by this transversal now, HG, that the alternate angles are equal. So we know that this angle here, angle 4 is equal to angle 2. Because of Prop 29 that says alternate angles are equal. So let's add this angle here, angle 5, to both sides. So if we add angle 5 to here and angle 5 to here, it preserves the equality. So angle 4 and angle 5 is equal to angle 2 and angle 5. But now let's look at the green parallelogram. In the green parallelogram, we know that this is parallel to this. And so we have two parallel lines cut by transversal. It makes the same side interior angles equal to each other. So here we use Prop 29 again, and we prove that angle 2 and 5 are equal to 2 right angles. Therefore, angles 4 and 5 must be equal to 2 right angles, which brings us into our Prop 14 situation. At the end of this line, at a point on this line, we have two lines, this green line, this blue line, coming together at opposite sides of this line. Their combination of angles equals 2 right angles. Therefore, this line, KH is in line with HM. Therefore, this is one continuous line. Therefore, we now have a parallel here and a parallel here. So we can prove that this is parallel to this. All right, we're almost there. We still need to prove that this is parallel to this. Well, we can do that by seeing, and we also need to prove that they're equal. So we know that we can prove they're parallel because we know that this line is parallel to this common line. But we already know this is parallel to this. So two lines parallel to the same line are therefore parallel to each other. That's Prop 30. Therefore, we can prove that KF is parallel to ML. With similar reasoning, we can prove, because we know through Prop 34, that in parallelogramic areas, the opposite sides are equal. We know this side is equal to this side. So KF is equal to HG. But by the same reasoning, in this green parallelogram, we know this side is equal to this side. So we know that HG is equal to ML. And two things equal to the same thing are equal to each other. Therefore, KE, this side, KF is therefore also equal to ML. So it's parallel to ML and it's equal to ML. So these lines are parallel and equal. And here's what we know if we use Prop 33, that if we have parallel lines that are equal, if we join them at the extremities, those lines that join two equal and parallel lines are themselves equal and parallel. Therefore, we have a parallelogram. We have parallelogram KFLM. This whole figure is one parallelogram. And since this whole parallelogram has two parts that equal these two parts, this whole parallelogram is equal to this whole quadrilateral, this whole rectilineal figure. And that's what we're trying to prove. So this is equal to A, B, C, D. And that's what we're trying to prove with our construction. And since we have done that, we can conclude QEF.